Welcome back for today's tutorial. Today we are going to discuss some advanced questions of projectile motion. The question number 1. A ball is kicked at an angle of 35 with the ground. What should be the initial velocity of the ball so that it hits a target that is 30 meters away at a height of 1.8 meters? B. What's the time for the ball to reach the target? This is the free body diagram. The ball is projected 35 degrees from the horizontal, and the horizontal distance is 30 meters, and the vertical distance is 1.8 meters. The question is to calculate the initial velocity, which is projected 35 degrees. Here is the solution. The displacement to the horizontal direction is 30 meters, and to the vertical direction is 1.8 meters, and the cos 35 0.82, sin 35 0.57, acceleration due to gravity minus 9.8 meters per second square. The required is the initial velocity and the time of flight. You know that the horizontal distance or the range equals the horizontal velocity times t. The horizontal distance or the range is given. This is the range, and this is the value of cos 35. So the horizontal distance equals or 30 equals 0.8 b naught t, and solving t gives t which equals 30 meters over 0.82 b naught. This is the range. This is also the horizontal component of the velocity. So the time of flight is t equals 30 meters over 0.82 b naught. This is the horizontal component of the velocity, and this is the range. Range over the horizontal velocity gives the time of flight. In vertical direction, vertical displacement at any point, at any time, which is changing y, equals this is a vertical displacement. When object is moving upward, the change in displacement and the change in y is positive because the final point is greater than the initial point. Change means final minus initial, not greater minus later. When an object is moving down, the change in displacement is negative because of the final point is less than the initial point. So a vertical displacement at any time as a function of time equals v naught t minus half gt squared, when v naught y is v naught sin 35, which is the vertical component of the velocity, 0.57 v naught. If you substitute question 3 and equation 1 into equation 2, Here is equation 3, and equation 9 is time. If you substitute the two equations into equation 2, gives 1.8 equals 0.57 v naught, 30 over 0.82 v naught minus 9.2 minus 9.8 over 2 times 30 meter over 0.82, the power of 2. This is the vertical component of the velocity. The vertical component of the velocity. This is a vertical displacement. This also, this and this are the time of flight. If you solve this equation, gives 18.33 meter per second. This is the vertical component of the velocity, which is projected at 35 degrees. Remember, these are some important notes about the projectile motion. Along the axis, the acceleration is uniform and equals minus g, and the velocity at any time t is given by v. This is the final velocity, the vertical direction, equals v naught sine theta minus gt. This is the velocity in the vertical direction at any time, at any function of time. Along the x-axis, the velocity vx is constant, and therefore the component x of the displacement is given by, this is the horizontal distance, so the range equals v naught cos theta times t. This is the range of the projectile. The horizontal component of the velocity is constant. Along the y-axis again, the motion is that of the uniform acceleration type, and the y component of the displacement is given by, this is the vertical displacement in the y-axis equals v naught sine theta, which is the vertical velocity, and this is the time of flight minus half gt squared. This is the vertical displacement of an object projected at some angle theta. It's at any time at a function of time. So this is the vertical component of the velocity. The vertical component of the velocity v naught sine theta minus gt. When it moves upward, it's positive. When it's moving downward, it's negative. At the maximum height of the turning point, remember, is 0. The shape of trajectory, or the path of the projectile. The shape of the trajectory followed by the projectile is found as follows. This is a horizontal distance of the range, which is a horizontal velocity times t. And solving t gives the range over the horizontal velocity. This is the time of flight. the time of flight equals the range over the horizontal component of the velocity. This also the vertical displacement of or the vertical displacement in the y-axis, which is the displacement at any time v naught y sine theta t minus half gt squared. If you substitute equation 1 into equation 2, you know that the time to the vertical direction equals the time to the horizontal direction. The projectile motion is the dimensional motion with common variable t. The time in the horizontal equals the time in the vertical. Now, in equation 1, you calculate the time. If you substitute the time to equation 2, give v naught sine theta x over v naught cos theta minus g over 2 v naught squared whole square theta x squared, or v naught is cancelled out by v naught. Sin theta over cos theta is tan theta, which is tan theta x, and this minus g over 2 minus g x squared over 2 times v naught squared cos squared theta, which gives this equation. Here is the coefficient of x squared. This is the coefficient of x squared. This is the coefficient of x. So this can be written as y equals ax squared plus bx, where a is the coefficient of x squared and b is the coefficient of x, where a is minus g over 2 v naught squared cos squared theta and b is tan theta. This is example 2. The trajectory of a projectile launched from a ground is given by the equation y equals minus 0.025x squared plus 0.5x, where x and y are the coordinates of the projectile on a rectangular system of axes. Find the initial velocity and the angle at which the projectile is launched. Here the required is the angle of projectile and the initial velocity. Here is the solution. Remember, the coefficient of x squared equals, this is the coefficient of x squared, which is a. This is also the coefficient of x, which is tan theta. So equation 1 and equation 2 are equal. If two equations are equal, the coefficient of x squared, one of the equation equals the coefficient of x squared to the other equation. The coefficient of x equation 1 equals the coefficient of x equation 2. The coefficient of x in equation 1 is tan theta, which is the coefficient of x. In equation 1 is tan theta, and in equation 2 is 0.5. Therefore, tan theta equals 0.5, which gives theta the tan inverse of 0.5, which is 26.5 degree. And here is the coefficient of x squared is minus 0.025, and the coefficient of x squared is minus g or 2 v naught squared whole squared theta. As we discussed, the coefficient of one of the equation equals to the coefficient of another equation if two equations are equal. Here is the coefficient of x squared is minus 0.025, and this is the coefficient of x squared in another equation. So the two equations are equal. Minus 0.025 equals the coefficient of x squared is a trajectory equation, and solving this problem gives v naught 15.6 meter per second. Question number 3. A ball is kicked from a ground level at an initial velocity of 60 meters per second and at an angle theta. The ground reaches a horizontal distance of 200 meters. A. What is the size of angle theta? B. What is the time of flight of the ball? Here is the required is an angle of projected and the time of flight. The horizontal distance is 200 meters. At the horizontal velocity 60 meters per second. This is a projectile motion, equation of projectile motion, which is 2 times v naught cos theta, v naught sin theta over g, equals the range. The range is 200 meters. Solving this, v naught square sin 2 theta equals 200 times acceleration due to gravity. This is the range, and this is also gravity. 2 times cos theta sin theta equals sin 2 theta. Mathematical expression. So v naught squared sin 2 theta gives 400 meters times acceleration due to gravity. And solving this, theta equals 16.5 degree, and the time of flight equals the range over the horizontal component of the velocity equals 3.48 seconds. A stone is thrown horizontally at 7.5 meters per second from a cliff that is 68.4 meters high. How far from the base of the cliff does the stone land? This equation is and the question is projected at the height of 68.4 meters and strike the ground, which is moving downward. So the change in displacement is negative in this case. The horizontal component of the velocity 7.5 meters per second. There is no vertical component of the velocity. In this case, the required is horizontal distance. Here is the vertical displacement minus 68.4 meters. Because of its negative, final point is less than the initial point. The change in displacement in the vertical direction is negative, and the horizontal component of the velocity is 7.5 meters per second, which is constant, and the acceleration due to gravity minus 9.8 meters per second squared, and the vertical component of the velocity is 0 because of there is no vertical component. Initially, the object is projected to the horizontal direction. Remember that the vertical displacement at any time is equals the vertical component of the velocity times time of flight t minus half gt squared. But in this case, this velocity is this velocity is 0. This gives minus 60.4 equals minus 9.8 t squared over 2, which gives t equals 3.7 second. And the horizontal direction is the horizontal velocity times t, which is 3.7 second times horizontal velocity 7.5 meter. This is the horizontal displacement or the range, which is 27.8 meter. This is the horizontal velocity, and this the time taken. The time to the horizontal direction is the same the time to the vertical direction, and the horizontal component of the velocity are 20 times constant. Thank you for watching. Please subscribe for the next tutorial. Thank you for watching. Please subscribe to get the next tutorial.